kids, welcome to today's maths class, and today we'll do playing with numbers. Our learning objectives are factors and multiple, even and odd prime, composite and co-prime numbers. Some properties of factors and multiples. Test of divisibility, palindromic numbers, prime factorizations, highest common factor HCF and least common factor LCM, and the properties of HCF and LCM. So first is factors and multiples. You have already studied but the factors and multiples in the previous class. In this chapter, the same concept shall be recapitulated and the new one learned. You know that the number 12 is divisible by 3, but 3 is not the only number that can divide. 12, 4, 6, 1 and 12 are the other numbers which can divide 12 too. All these numbers are the factors of 12. So all these numbers 4, 6, 1 and 12, they will divide the 12 exactly. So all these numbers are the factor of 12. Hence, the factors of a number can exactly divide the number, and the number are called the multiples of any of its factor. Now we'll take an example. Let's take number 24. 3 into 8, 24. 6 into 4, 24. 2 into 12, 24. 1 into 24, that is equals to 24. As you can see, 1, 2, 3, 4, 6 and 8 and 12 can divide 24 exactly. Hence, they are the factor of 24, and 24 is the multiple of each of these numbers 1, 2, 3, 4, 6, 8 and 12. Clear? So here we have taken number 24. So 3, 8, 6, 4, 2, 12 and 1 and 24. All these will be the factors of 24, and 24 will be multiple of all these numbers. Clear? So this is how we can find the factors and multiples. Next is fact 5. Note that the factors of the colored and underlined factors are the same, and only their positions are changed. As such, the moment any factor is to repeat itself, stop your operation. For example, in case of factors of 64, 1 into 64, that is 64, 2 into 32, 64, 4 into 16, that is 64, 8 into 8, that is again 64. Clear? Now again 16 aa jayega, so repeating, so we'll stop it here. Clear? Stop here at 16 because the factor 16 has already been arrived at, because 4 into 16 is same as 16 into 4, so 16 repeat ho raha hai, so we'll stop it there only. Second A, by multiply 16 by 1, 2, 3, 4 and 5, we obtain the multiple of 16. The multiple of 16 are 16, 32, 48, 64 and 80. Multiple of 25, 25, 50, 75, 100 and 125. Multiples of 40, 40, 80, 120, 160 and 200. Next is different type of numbers according to their factors and multiples. First one, even numbers. The numbers which are divisible by 2 are called even numbers. The unit digit in such numbers is always the multiple of 2. For example, 2, 4, 6, 8, 12, 48, 576, all these are even numbers. So number which are exactly divisible by 2 or the unit digit is 0, 2, 4, 6 or 8, they are even numbers. Next is odd numbers. The numbers which are not divisible by 2 called odd numbers. The unit digit in such numbers is always odd. For example, 1, 3, 5, 9, 15, 21, 23, 8467, all these are odd numbers. So all these numbers are not exactly divisible by 2. And the unit digit, like here, it is 7, here it is 3, here it is 1. All these are odd numbers. Clear? Next are prime numbers. Prime numbers, the number which are exactly divisible by 1 and the number itself are called prime numbers. For example, 2, 3, 5, 7, 11, 13, 17, 23, etc. All these are prime numbers. They are divisible by 1 or by the number itself. Means 2 है 1 से divisible होगा और 2 से. 3, 1 and 3. So all these are prime numbers. Next is composite numbers. The numbers which have more than 2 factors are called composite number. For example, 6, 12, 28, 32, 9, 14, all these are composite number because they have more than 2 factors. Next is co-primes. If two numbers do not have any common factor other than 1, they are said to be co-prime numbers with respect to each other. For example, 3 and 7. 3 and 7 में 1 के अलावा और कोई भी common factor नहीं है, so they are co-prime numbers. 7 and 12, 13 and 24, 8 and 15 are co-prime numbers. All the consecutive numbers like 2 and 3, 3 and 4, 4 and 5, they are co-prime numbers. Next is some important observations. The number 1 is neither prime nor composite. The number 2 is the smallest prime number and also the only even number that is prime. The prime numbers are always co-prime, but two co-prime numbers may not be prime numbers. For example, 8 and 15 are co-prime number, but both are composite numbers. 7 and 12 are co-prime, but here the 7 is prime number, but 12 is composite number. Next is activity. Greek mathematician Aristophanes in the 3rd century BCE. Let us see the method. List the number from 1 to 100 on shown below. Here number 1 to hundreds are given. We will find out which are prime and which are composite. So for that, cross out 1 because it is not a prime number. So first we'll cross out 1 because it's not a prime number. Then encircle 2 because it's a prime number. And we will cross out all the multiples of 2 other than 2 itself. Like multiples of 2 that are 4, 6, 8, 10. So we'll cross out all the multiples of 2 till 100. You will find that the next uncrossed number, that is 3. Encircle 3 and cross out all the multiples of 3 like 6, 12, 15 like this. The next uncrossed number is 5. Encircle 5 and cross out all the multiples of 5 other than 5 itself. Continue this process till all the numbers in the list are either encircled or crossed out. Now here, all the encircled number, they are prime numbers. Clear? And all the cross out numbers other than 1, they are composite number. This method is called the sieve of Aristophanes. Means by using this method we can separate the prime and composite numbers. Next is try these. Observe that 2 into 3 plus 1, that is 7, that is a prime number. Here 1 has been added to the multiple of 2 to get the prime numbers. Can you find some more numbers of this type? Like here 2 into 2, that is 4 plus 1, that is 5, and 5 is a prime number. Clear? Next is result. All the circle numbers are the prime numbers and they are the only 25 between 1 to 100. So 1 to 100 के बीच पे 25 prime numbers. They are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. Clear? So all the cross number except 1 are the composite number. Obviously, They are 74. The number 1 is, though crossed out, not a composite number and already explained because 1 is neither prime nor composite. The above process is finding all the prime numbers less than the given number are called the sieve of Aristophanes in honor of the Greek mathematician Aristophanes. Number 2 is the smallest and the only even prime number because all other prime numbers are odd. All other prime numbers are odd. A number greater than 1 is either a prime or has a factor which is prime. For example, 12, that can be written as 1 into 12, or we can write it as 1 into 2 into 6, or 1 into 2 into 2 into 3. Finally, only the prime will be left as a factor. There is a statement which says that every even number greater than 2 can be expressed as the sum of two prime numbers. For example, 8 can be written as 3 plus 5. The statement is called Goldbach's construction. It is a construction because it has not yet been proven. Prime numbers such as 5 and 7 that differ by 2 are called twin prime numbers. Mathematicians believe that there are an infinite number of pairs of twin primes. Like here, these two numbers are twin prime numbers because their difference is 2. So, all these prime numbers, their difference is 2 are called twin prime numbers. Clear? Here are more examples for you. For example, express each of the following number as the sum of two odd primes. First is 32. So, 32 can be written as 3 plus 29. So, what will we do to find out this? Take the smallest odd prime, which is 3. Odd prime liya humne, that is 3. Now work out difference of 32 and 3. So 32 minus 3, that is 29. 29 is also prime number. So 3 plus 29, that is 32. Clear? Next is a fact file. There can be more than one right answer to the above question. For example, 5 plus 7 plus 23, that is also 35. So, we can make different combination. Clear? Next is some properties of factors and multiples. Property 1. If A is the factor of B and B is the factor of C, then A is the factor of C. For example, we know that 3 is the factor of 9 and 9 is the factor of 27. Then 3 is also the factor of 27. Clear? Next, property 2. If A and B are primes and both are the factors of number C, then their product A into B is also the factor of C. For example, we know that 3 and 5 are primes and both are the factor of 30. Then the product 3 into 5, that is 15, is also factor of 30. Clear? Next is property 3. If A is the factor of two numbers B and C, then A is the factor of their sum B plus C. We know that 2 is the factor of 16 and 32. Therefore, 2 must be the factor of 16 plus 32, that is 48. We checked, we find that 2 is the factor of 48. Property 4. If A is the factor of two numbers B and C, then A is also the factor of B minus C, where B is greater than C. For example, 2 is the factor of 32 and 16. Therefore, 2 must be the factor of 32 minus 16, means their difference, that is 16. When checked, we find that 2 is the factor of 16. Clear? Next is some important observations. A natural numbers that exactly divide the given number is called the factor of given number. A number is said to be the multiple of any of its factor. Multiple of a number can get by multiplying the number by 1, 2, 3 and so on. The prime number has only two factors, namely 1 and the number itself. The composite number has at least one factor other than itself and 1. Next is exercise 2.1. Computational thinking. Write all the factors of each of the following. First is 19. 19 is a prime number. So it have only two factors. 1 and 19. That is number itself. Clear? So practice all the questions of this exercise. Next is test of divisibility. There are some shortcuts for determining whether one number is divisible by another number. This method is called the test of divisibility as shown below. Divisibility by 2, 5 and 10. For 2, the last digit, unit digit, that should be 0, 2, 4, 6 or 8. For example, 10, 22, 34, 46, 58. They are divisible by 2 because the unit digit, here it is 8, 6, 4, 2 and 0. So all these numbers are divisible by 2. Divisibility by 5, the unit digit should be 0 or 5. Like 20 and 35, that are divisible by 5. For divisibility by 10, the unit digit should be 0. Like 30 and 40, they are divisible by 10. Next is divisible by 3 and 9. For checking whether the given number is divisible by 3, for that, the sum of digit, that should be divisible by 3. Like 48. So sum of digit 4 plus 8, that is 12, and 12 is divisible by 3. So the given number 48 is divisible by 3. For 9, the same. The sum of digits should be divisible by 9. Like 63. 6 plus 3, that is 9. So it is divisible by 9. Next, divisible by 4 and 8. A number is divisible by 4 if the last two digit is divisible by 4. Like here, 148. Last two digit, that is 48. Clear? So, 48 is divisible by 4. That means the given number 148 is divisible by 4. Next, a number is divisible by 8 if the last three digits are divisible by 8. Like here, 4325. So last three digits are 325, which is not divisible by 8. So the given number is not divisible by 8. A number is divisible by 11 if the difference between the sum of the odd digit in the odd places and the sum of digit in the even places is equal to 0 or the multiple of 11. For example, here consider number 6732. So sum of the digit at odd places, 6 plus 3, that is 9, and sum of digit at even place, that is 7 plus 2, that is 9. The difference is 0. That means the given number is divisible by 11. Both of the above number are divisible by 11. In the first case, the difference is 0, and in the other case, the difference is divisible by 11. Clear? First case में difference 0 है. In second case, that is 11. So both the numbers are divisible by 11. Now we'll take an example. Test. Each of the following numbers is divisible by 2, 3, 5 and 9. First number is 672. So divisible by 2, the unit digit is 2. So the given number is divisible by 2. For 3, the sum of digits 6 plus 7 plus 2, that is 15. That means the given number is divisible by 3 also. For 5, the unit digit should be either 0 or 5. Here it is not. So this given number is not divisible by 5. For 9, the sum of digits should be divisible by 9. So 6 plus 7 plus 2, that is 15, and 15 is not divisible by 9. So the given number is not divisible by 9. This is how we can check. Next is palindromic numbers. A palindromic number is one which read the same forward and backward. Some examples are 121, 2332, 12,34,321, etc. Can you show that all palindromic number with an even number of digits are divisible by 11? You can create your own palindromic number using addition. Pick up the number 245. Then reverse the digit to create the new number. Reverse करेंगे तो क्या हो जाएगा 542. Next add the number जो हमने reverse करके किया है and the original number. We will add them together. We'll get 787. So here we have created a new palindromic numbers. Sometime you have to keep reversing and adding to create the palindromic number. For example, 67 plus 76, that is 143. Now 143 reverse करेंगे 341, add करेंगे 484. That is a palindromic number. Clear? Next, some important observations. A number is divisible by 5, its last digit is either 0 or 5. The number is divisible by 2 if its last digit is 0, 2, 4, 6 or 8. The number is divisible by 3 if the sum of its digit is divisible by 3. The number is divisible by 11 if the difference of the sum of digit at odd place and the sum of digit at even place is either 0 or the multiple of 11. Next is exercise 2.2. Computational thinking. For the following statement, write T for true and F for false. If the number is divisible by 3, it must be divisible by 9. That is false. Clear? So practice all the questions. Next is prime factorization. Every natural number except 1 is either a prime number or the composite number. A composite number can be expressed as the product of two or more prime numbers, which are called prime factors. The process of decomposition of composite number into prime factors is known as prime factorization. For example, 18 can be written as 2 into 3 into 3 as the product of prime numbers. 30 can be written as 2 into 3 into 5. So this is called prime factorization. 2, 3 and 5 are called the prime factors of 30. The factor tree can be used to express the composite number as the product of its prime number. The factor tree on your right illustrate the prime factorization of 210. Remember, every composite number has one and only one prime factorization. Prime factorization can be obtained by the division method also. So here it is the factor tree method 210. So we can write it as 21 into 10. Here 21 and 10 both are composite number. So further we can written it 7 into 3 और 21 को अगर 3 से डिवाइड करेंगे तो क्या आ जाएगा 7 आ जाएगा. So we can write it 7 into 3 and 10 can be written as 2 into 5. Here all these numbers are prime numbers. So prime factorization of 210, that is equals to 2 into 3 into 5 into 7. Next method, we can also do prime factorization by division method. Now we will take example, find the prime factorization of 252. So here we are using factor tree method. First method, first 252. Smallest prime number which can divide it exactly, that is 2. So 126 aa jayega. 2 is a prime number. So here 126 is a composite number. Again we will divide by 2, we will get 63. Now it cannot be divided by 2, so we will divide by 3. Prime number को as it is लिखेंगे and composite number को आगे divide करते रहेंगे. 3 से divide करेंगे we will get 21. Again 3 से divide करेंगे we will get 7. So here all these numbers 2 into 2 into 3 into 3 into 7. These are prime numbers and this is the prime factorization of 252. Another method, division method. 2 से divide करेंगे 126, again 2 से करेंगे 63, 3 से करेंगे 21, then again we'll divide by 3. So we'll get 7. 7 is a prime number, so we'll divide by 7 and last में आ जाएगा 1. Till here we'll do division. So 2 into 2 into 3 into 3 into 7. That is the prime factorization of 252. Clear? Next is index notation. To be brief, we write 5 into 5 as 5 is to power 2 and read it as 5 square or square of 5. 5 into 5 into 5, that can be written as 5 is to power 3 or 5 cube. Read as 5 cube or cube of 5. 5 into 5 into 5 into 5 can be written as 5 is to power 4 and read as 5 to power of 4. Similarly, a into a can be written as a is to power 3 and read as cubed or cube of a, and so on. This index notation gives us the more precise method of expressing the factors of a number. 12 can be written as 2 into 2 into 3, or we can write it as 2 is to power 2. 2 into 2 can be written as 2 is to power 2 into 3. 40 can be written as 2 is to power 3 into 5. 60 can be written as 2 is to power 2 into 3 into 5. Clear? Next, some important observations. Expressing a number as the product of prime factors is called prime factorization. Expressing the prime factors in power form is called index notation. Next is exercise 2.3. Subject enrichment. Find the prime factorization of each of the following number. First one is 48. So you can use factor tree method or division method. I am using division method. So 48 divide by 2, 24. Again divide by 2, 12, 6. So prime factorization of 48, that will be 2 into 2 into 2 into 2 into 3, or we can write 2 is to power 4 into 3. Clear? Next is highest common factor or HCF. The highest common factor HCF of two or more given number is the greatest number which can divide all the given number. For example, consider the factors of 12 and 18. So these are the factors of 12 and 18. Now we'll write the common factor. Common factors are 1, 2, 3 and 6. Among these, which one is the highest? 6. Clear? The greatest of them is 6. So 6 is the highest common factor of 12 and 18. So HCF क्या हो जाएगा? 6. Clear? Next is method of finding highest common factors. Of all methods of finding HCF, the two commonly used methods are the prime factorization method and the continued division method. So method 1, that is prime factorization method. For finding HCF of 24 and 36, we shall proceed as under. So prime factorization method, 2 से divide करेंगे we'll get 12 and 18. Again 2 से करेंगे 6 and 9. Then we'll divide by 3. We'll get 2 and 3. 1 is their only common factor. And here 2 and 3 they are prime numbers. So HCF क्या हो जाएगा? 2 into 2 into 3. 12 says 2 into 2 into 3 are the common factors. ये common factors है. So the factor of 24 here, these are the factors 24 and 36. Now common factors हम देखेंगे, that is 1, 2, 3, 4 and 6 and 12. Among these, which is the highest? That is 12. So HCF will be 12. The method of prime factorization is easy and short. Now we'll take an example. Find the HCF of number in each of the following by prime factorization. 47 and 61. So 47 and 61. Now 1 is their common factor. So HCF क्या हो जाएगा? 1. Because इन दोनों में इसके अलावा कोई भी common factor नहीं है. Only 1 is the common factor. So HCF क्या हो जाएगा? 1. 47 and 61 are prime numbers and such have no common factor other than 1. So their HCF will be 1. Next is method 2. That is continued division method. This method is suitable to obtain the HCF of bigger number. To find the HCF of two numbers by this method, we perform the following steps. Step 1. Divide the greater number by the smaller number. Check for the remainder. If the remainder is 0, then the smaller number is the HCF, otherwise go to step 3. Divide the smaller number by the remainder. Continue the process as long as the remainder obtained is not 0. When the remainder becomes 0, the HCF is the last divisor. When there are more than 2 numbers, when we have to find the HCF of more than 2 numbers, we will follow following steps. Step 1. Find the HCF of 2 smaller number as explained above. जैसे हमने पहले किया था, first 2 smaller number लेंगे and we'll find their HCF. Then find the HCF of 2 numbers and the next number and so on. Now we'll take an example. Determine the HCF of each of the following number by continued division method. So our number are 392 and 1386. So greater number को हम smaller number से divide करेंगे. First we have divided 3 times होगा, subtract किया 210. Now 210 become the divisor. 392 become our new dividend. Divide करेंगे 1 time हो जाएगा. 210 subtract करेंगे 182. 182 is our divisor and 210 become new dividend. So 1 time divide होगा, that is 182 subtract करेंगे. So what will get? 28. Now 182 will become our new dividend. 6 time हो जाएगा, subtract करेंगे 14 and 28 become our new dividend. So 2 time and में will get 0. So last divisor was 14. So 14 will be the HCF of given numbers. Clear? Next is question involving remainder. Here is an example for the remainder question. For example, find the largest number which divide 245 and 1029, leaving remainder 5 in each case. So in this case, remainder 5. 5 means 5 बच रहा है, that is extra. So what we'll do? We will subtract 5 from 245 and 1029. So we'll get 240 and 1024. Now we will find their HCF. So here HCF 2 into 2 into 2 into 2, that is 16. Clear? So this is how we'll find the HCF. Next, use of HCF in solving problems. 3 monkeys climb 18 meter, 45 meter and 72 meter respectively. Find the length of the longest step that can measure these distance exactly. Solution. The longest step that can measure 18 meter, 45 meter and 72 meter exactly is the HCF of all these numbers. So we'll find the HCF. Here we have used the log division method. Last divisor was 9. So HCF क्या हो जाएगा? 9. So the longest step required to measure 18 meter, 45 meter and 72 meter, that will be 9 meter. Clear? Next is some important observations. The highest of the common factor HCF of 2 or more number is called their HCF. The HCF of 2 numbers that do not have any common factor other than 1 if the number are co-prime is always 1. Next is exercise 2.4. Critical thinking, write T for true and F for false of each of the following statement. The HCF of 2 distinct prime number is 1. That is true because they do not have any other common factor than 1. Clear? Practice all the questions of this exercise. Next is least common multiple or LCM. It is the number which is the common multiple of 2 or more numbers and is the smallest among 2 common multiple. For example, take the multiples of 3 and 4. So here we have taken the multiples of 3 and 4. Smallest common multiple that is 12. So LCM क्या हो जाएगा? 12. Next, method of finding least common multiple or LCM. There are two alternative methods of finding LCM of two or more numbers. Let us study the following example to study these methods. Now we will take an example, find the LCM of 18, 24 and 36. So first we will do the prime factorization of given numbers. So 18 का हो जाएगा 2 into 3 is to power 2, 24 2 is to power 3 into 3, 36 2 is to power 2 into 3 is to power 2. Take all type of factors. So क्या हो जाएगा, all type of factor and common factors. So हो जाएगा 2 into 3 into 3 into 2 into 2. So what we'll do, we will write the highest power like 2 और 3 है यहाँ पे फैक्टर्स में. सो 2 की हाईएस्ट पावर कितनी है 3. सो विल राइट 2 is to power 3 मल्टीप्लाई बाय 3 की हाईएस्ट पावर 2 है 3 is to power 2. That is equals to 72. Clear? That will be the LCM. Next, by alternative division method. So here we will divide 18, 24 and 36. 2 से डिवाइड करेंगे 9, 12 and 18. 9 cannot be divided by 2, but 12 and 18 can be. So we'll divide by 2. 9 को as it is कैरी फॉरवर्ड करेंगे, ये हो जाएगा 9, 6 and 9. Now we'll divide by 3. So we'll get 3, 2 and 3. Again we'll divide by 3. So we'll get 1, 2 and 1. Here we'll stop dividing when any two of the number have no common factor except 1. So LCM of 18, 24 and 36 is 2 into 2 into 3 into 3 into 1 into 2 into 1. That is 72. Clear? Next is question involving remainder. Find the least number of 3 digit that is divisible by 25, 40 and 60, leaving the remainder 9 in each case. First let us find the least number that is divisible by 25, 40 and 60 respectively. So we will find their LCM, that is 600. The least number that divide 25, 40 and 60, leaving the remainder 9 हो जाएगा, उसमें हम 9 ऐड कर देंगे, that is 609. Clear? Next, use of LCM in solving problems. We'll take an example, determine the two numbers nearest to 10,000 which are exactly divisible by each of 2, 3, 4, 5, 6, 7. To solve the problem, first we'll find the LCM of 2, 3, 4, 5, 6, 7. So LCM is 420. Now what we'll do? We'll divide 10,000 by 420. So divide करेंगे, लास्ट में रिमाइंडर हो जाएगा 340. So now if we subtract 340 from 10,000, the new number will be exactly divisible because 340 is extra here. This is remainder. So 10,000 में से 340 हम subtract कर देंगे. So the new number that will be exactly divisible by 2, 3, 4, 6 and 7. So the new number is 9660. Clear? Now if we add the difference of 420 and 340 to 10,000, the new number will be exactly divisible by 2, 3, 4, 5, 6 and 7. So here what we have done. Now what we'll do? We'll add the difference of 420, the LCM and 340 to the 10,000. जो new number आएगा that is exactly divisible by 2, 3, 4, 5, 6 and 7. Next is relation between HCF and LCM. The product of HCF and LCM of two number A and B is equal to their product A into B. We'll take an example. The HCF and LCM of two number is 13 and 1989 respectively. If one of the number is 117, find the other number. So as we know, the product of two number is equal to the product of their HCF and LCM. Suppose the other number is x, then x into 117 equals 13 into 1989. So x equals to क्या हो जाएगा इनका जो प्रोडक्ट है विल डिवाइडेड बाय 117. So the other number will be 221. Clear? Next is properties of HCF and LCM. The HCF of a set of number will be less than the number or equal to the smallest of these numbers. The LCM of the set of a number will be greater or equal to the largest of these numbers. The HCF of a number A and B is the factor of LCM of A and B. At the same time, LCM of A and B is the multiple of HCF of A and B. If the HCF of two numbers is one of the number, the LCM of the number is the other number. The LCM of two co-prime numbers is equal to their product. The product of the HCF and LCM of two numbers A and B is equal to their product A into B. Next, some important observations. The least of the common multiple of two or more numbers is called their LCM. HCF of two co-prime numbers is 1. LCM of two co-prime number is their product. The product of HCF and LCM of two numbers is equal to the product of those numbers. Next is exercise 2.5. Critical thinking. Determine the LCM of the number in each of the following. First is 18 and 77. So 18 and 77. So here I am using division method. Then 3. 3 these are 9. $77. Now next number is 7. So LCM क्या हो जाएगा? 2 into 3 into 3 into 7 into 11. So LCM equals to 2 into 3 into 3 into 7 into 11. 3 to the 6, 18, 18 and 11 into 7, 77. So here we can note down one thing. 18 and 77, they are co-prime numbers, so their LCM will be equal to their product 18 and 77. So 18 into 77, 5 carry over, 7 plus 1, 8, 1386. That will be the LCM. Clear? So practice all the questions of this exercise. Next is, let's recall. Take the correct option. Which of the following number is exactly divisible by 4? For divisibility by 4, last two digit, that should be divisible by 4. So here, this number last two digits 0, 2 hai, so that is not divisible by 4. 32 is divisible by 4. So this number will be divisible by 4. So B is the correct option here. So here we end the chapter. I hope you understand it well. Now you to practice it.